Hi everyone. Okay, so we're going to be doing our last tutorial here on Anova. So the difference between a t-test and an Anova is that the independent variable measured at the categorical level actually has more than two levels to it. So in the example of a t-test, would be that our independent variable at the categorical level would be something like gender, which has, let's say, two levels, which would be male and female gender. For Anova, we're still having the IV at the categorical level. It just has another factor added on. So it has to have at least three or more levels to that one categorical variable. So today we will be looking at political affiliation. So political affiliation is measured at the categorical level, but it has three different levels here. So people can either be considered conservative, liberal, or NDP. If we were only looking at two polar ends of the political spectrum, such as looking at the differences between conservatives and people that are a bit more socialist, so people that would fall into NDP. If we were only looking at those two levels, then we could run a t-test. But because we're also looking at liberal, there is three or more levels, so we have to run an Anova and cannot run a t-test. Okay. And similar to a t-test, the dependent variable has to be measured at the continuous level. So it has to be measured, the measurement has to be at the interval or ratio level. So the dependent variable that we'll be looking at today is total social media use for any purpose during the week. So that's a numeric number. We're just counting how many times we're using different social media platforms. So we're counting a frequency. And so since that can be represented numerically, it's at the ratio level. So that kind of tackles some of the main assumptions to run the Anova in the first place. Your IV has to be at the categorical level and the DV has to be at the continuous level. Another assumption is that the DV has to be normally distributed, so there shouldn't be any outliers. So that's something you do during data cleaning. So you look at the normality plot and you look at any skewness and kurtosis issues, and then seeing from the scatter plots that we have created in the past if there is any outliers. If there are, then you would have to go and deal with them and then rerun your normality tests. For the purpose of this lab, we're not going to check this assumption, and we're just going to assume that everything is normally distributed. The other assumption, which is also an assumption for a t-test, is that the independent variables should also have equal variances across the different groups. So last time we checked this through the Levene's test of homogeneity of variance. So we want the variability to be similar across the different groups of the IV. So we can actually test this assumption as we run the statistic, and then based on the result of that, we can read different lines of the statistical analysis to determine which p-value, which t-value are appropriate to interpret. Because this is not a t-test, Anova actually has f-values. So we'll be looking at the f-value of the Anova statistic and the p-value associated with that. The last assumption is that the sample is random. So first off, we're going to start by writing down our alternative and null hypotheses for each IV. Okay, So basically, we will have to write out statements as such. So the null hypothesis is always that there are no differences between the groups on the DV. Because we have 3 groups, we have to say that there's going to be no difference between each of these 3 groups. Because really what the Anova is testing, which is similar to the t-test, is that people are scoring differently on the DV depending on what category you belong to at the IV level. Okay, so the null hypothesis is that there is no difference of how people score in the DV, no matter what group you belong to. And because the Anova has 3 groups, we actually have to state there's going to be no difference in, total social media use across conservatives, liberals, and people who are NDP. Now, the alternative would be there is a difference in social media use between conservatives, liberals, and NDP. So we can actually state where we think the groups may vary. For example, we might have research that suggests that, conservatives actually use social media way more than liberals, okay? But liberals and NDP are probably at the same level social media use, and so then both of those groups will differ from the conservatives. That might be the case, and that might be what research supports, but our alternative hypothesis has to stay two-tailed, which means that we can't really go ahead and state a direction of our hypotheses. So all we'll have to say is that there will be difference of social media use between conservatives, liberals, and NDP, which allows us to stay open to any differences that might occur among these 3 groups. So after we established our hypotheses for each of the IVs, we run through the assumptions, all 5 assumptions, to see if we're okay to proceed with the statistics. So assumption 1 and 2 are met because of our variables that we selected. So our IVs at the categorical, the DVs at the continuous. Assumption 3 is met because we just assumed, let's just assume we already did the data cleaning, outliers were taken care of, and everything was normally distributed for each DV. Assumption 4 will be the test of homogeneity of variance. And so we're going to test that assumption as we run the Anova itself. And then assumption 5 is already met based on our sampling strategy for the data set. So we just randomly sampled the population. There's no method of only sampling a subset of the population. Okay, so we're good to go ahead here and start running the Anova. So we'll open our data set here. Okay. So we're going to go into Analyze, Compare Means, which was the same drop-down tab that we used to run the t-test. And as you can see, the t-tests the options are here as well, but we're going to be running the one-way Anova. So in the factor section here, we're going to want to put our IV, so our categorical IV in there, which is political affiliation. Okay, and under this dependent list section is where the dependent variable goes at the continuous level. Okay, so total social media use across the week. Now we're going to click on Post-Hoc here, and what the Post-Hoc is going to do is that it's going to compare every single group to each other. So conservatives will be compared to NDP, conservatives will be compared to liberal, and then liberal compared to NDP, etc. Okay, so there's going to be all of these two-way comparisons like a t-test, and that's basically what the Post-Hoc is doing. It's just a bunch of t-tests done to compare two groups at one time, and it'll compare each group to each other so we know where the differences lies across the three groups. So we're going to go ahead and click on this option here. So if our equal variances are assumed, the correct or the most used post-hoc test is the Tukey's test, because it is a conservative test which takes into consideration multiple comparisons, okay? But it's not overly conservative, which means that we're kind of likely to see statistical significance, but it does take care of the error. In terms of if our variances are not equally assumed, we would use the James-Howell here, which does a correction for having unequal variances, and it's a very conservative test. If we go into options here, we can grab all of our descriptive information instead of running the descriptives on its own. So we'll go ahead and do that, and it'll show us all of the means of each group, which helps us interpret the post-hocs to know which group is different from each other and how are they different. Is one group higher than the other, etc. So this is really valuable information. So we're going to click on fixed and random effects as well. The homogeneity of variance test, we'll click that off to get our Levene statistic. And we'll also click off the Welch correction in case we actually, don't meet the homogeneity of variance assumption. We'll also click on means plot, which will plot our means on a nice graph, which makes a nice visualization of the results as well, if we prefer to kind of eyeball the results instead of necessarily looking at the means itself. So then we'll click continue. And then OK. And then we will have all of our results here. So this first box are the descriptive statistics, okay? So we're really only interested in looking at this stuff right here. So as we can see how many people responded and were each political affiliation, how many were in each group, okay? So there's a lot more in the liberal group. And then we have the means on the DV for each group. So we can kind of already see that conservative and liberals have a similar social media use on a weekly basis, whereas the people who affiliate as more socialist or NUP have a higher social media use. Okay, but we don't know if these groups are really that different until we run the statistical analysis. But this is kind of just something that we can see preliminarily. So if we're interested to check off our assumption for number 4, is there homogeneity of variance amongst the three groups? We will look at the Levene statistic, okay? And what we're hoping for is that the Levene statistic is non-significant, okay? We don't want it to be statistically significant. If it's statistically significant, it's saying that it's detecting that each group's variance is different from each other. Here, under the significance table, we see that this is the p-value associated with this test, and we see that it's not statistically significant, which means that we've met the assumption and that, the variances are heterogeneous, which means that they're similar across the three groups. So we've met the assumption for number 4. Now, the other box that we really are interested in looking at is the Anova, okay? And this box is your statistical analysis of the test. All that this box can tell you is that to reject or accept your null hypothesis, which is that are there differences between the groups, yes or no, based on the DV, okay? So we will look at the between groups line because we're interested to see if the groups are different from each other on the DV, okay? And if we look at the S statistic here, that's replaces the T statistic in the t-test, okay? So that's the information that you'll need. So you'll need the S statistic here and the p-value associated with it. So here we can see that the p-value is below 0.05, our cutoff value, which means that it's statistically significant. What that means for, in simple language, is that this test is picking up that the means are different depending on which group you belong to, okay? So as we kind of saw up here in the means, it's picking up that there are differences between these three numbers, okay? But we're not sure which groups are different from each other. We just know at least one group is different from at least one other group in this test. So to gain more information about which groups are different from each other on the DV, this is where we look at our multiple comparisons post-hoc test. So because our assumption for homogeneity of variance was met, we're actually going to read only the two key results. So the game's how results were if that assumption was not met, okay? So we're really going to focus on this upper rows here. So the first line is comparing NDP to liberals and then NDP to conservatives, okay? And so here this box shows you the numeric amount of mean difference. So if we took the mean of NDP and minused it from the mean of liberal, it's a positive number. So it's 0.51, okay? Which means that the NDP mean is actually higher than the liberal mean. And we can actually see that here. The NDP mean is higher than the liberal mean, and if we minus them from each other, we will get this numeric number, okay? So that just gives you quick information instead of having to do the subtraction yourself. So to know if this mean difference is actually statistically significant, we're actually going to look at the significance test here, which is our p-value, okay? And it's saying, yes, this mean difference is statistically significant. So these two groups are different on their weekly social media use, okay? And the NDP people actually use social media more than the liberals. So you'll need to use those two pieces of information. Now, if we compare NDP to conservatives, we can see that the mean difference is 0.49. So meaning again, NDP are scoring higher on social media use than conservatives. And that is a statistical significant mean difference, okay? Now, if we compare liberal to NDP, we're seeing that same comparison, but minus, because now we're using the liberals mean, which is lower mean, minus the NDP. So you'll see a lot of repetitive comparisons, okay? And so you only have to report a single comparison every single time. You'll see a lot of repetition, okay? So one of the comparisons that we haven't made yet are liberal versus conservatives. We know what NDP versus conservatives are, but we never compared liberal versus conservative. So if we compare these two means, there is a negative difference, okay? But this is not statistically significant. Now, if we go up to the descriptive box and we look at the liberal mean and the conservative mean, we'll see that they're actually very similar to each other, okay? So the liberal mean 2.82 minus 2.84 is getting you that negative 0.02 difference, okay? And it's saying that these two means aren't very different from each other, and we can see that it's very, very close to each other. So they actually consume the same amount of social media on a weekly basis, okay? So there's no difference between those two groups. So we've already made these kind of comparisons here. So conservative against NDP, which was already up here, and then conservative versus liberal, which was already up here, okay? So now we're just seeing the signs being flipped and that comparison being repeated. So now you have all your information for interpretation. So you'll need the statistical significance between the two groups, were they significantly different or not, but you also have to say the direction. So what group was higher or lower than the other one? Now for your own kind of visualization, you can see here that NDP was scoring way higher on total social media weekly usage, and liberal and conservative were scoring way lower than this mean here. But the liberal and conservative means were very close to each other. Okay, so that's just another way that you can visualize this, but obviously you will have to check it in your multiple comparisons and as well as in your Anova test. So we've actually gone through everything here. So all that is really left is for you to summarize all of these results, okay? So, you know, the result for the ANOVA, were there differences between the groups, yes or no? So what does that mean for your null and alternative hypothesis? Then looking at the post-hocs, which comparisons were different from each other, which groups were higher or lower, and then to summarize in simple language, what can you really say about these results if you're trying to tell someone information about how political affiliation is different across, how social media use is different across political affiliation, okay? And then you also want to talk about meeting your assumptions. So usually you want to talk about meeting your assumptions first, then interpreting the ANOVA box, rejecting or accepting the null hypothesis, and then going down to your post-hoc comparisons and interpreting all that, and then end with a general simple language statement. So you won't have to submit the database here for this assignment, but I'll just need your document as a group assignment. And please post this on Brightspace if you can. All right, thank you.